Now let's try graphing on the number line in the integers universe. B greater than negative 2. Integers includes negative numbers. Negative 1 is greater than negative 2, so our answer starts there. 0 and all of the positive numbers are also greater than negative 2, so I have to put dots on them all and continue forever in the positive direction. I cannot include negative 2 in my answer because it is not greater than itself. C less than negative 3. Negative 4 is less than negative 3. So is negative 5. And continuing onwards forever in the negative direction. But I cannot include negative 3 because it is not less than itself. D greater than 2. Well, this looks the same as it would in a natural numbers question. 3 and 4 are greater than 2. 2 isn't, and we go on forever in the positive direction. E less than 1. 0 is less than 1. And so are all the negative numbers. And then we go on forever in the negative direction. 1 is not less than 1, so it cannot be included in the answer. Let's try a few more examples of graphing in integers. These ones have the or equal to sign in the symbol. Y greater than or equal to negative 2. Negative 2 is equal to negative 2, and negative 1, 0, and all of the positive numbers are greater than negative 2, so they are included in the answer, going on forever in the positive direction. F is less than or equal to negative 3. Negative 4 is less than or equal to negative 3. Negative 5 is less than or equal to negative 3, and it will go on forever in the negative direction. Negative 3 is equal to negative 3, so it's part of the answer too. G greater than or equal to 2. Again, it looks like the natural numbers answer to the same equation. 3 and 4 are greater than 2. It goes on forever in the positive direction, but we have to include 2 because it is equal to 2. E less than or equal to 1. Well, 1 is equal to 1, and 0 and all of the negative numbers are less than 1, going on forever in the negative direction. Now let's try graphing on the number line in the real numbers universe. M greater than or equal to negative 1. Well, we know negative 1 is equal to negative 1, so we put a dot on it. We know all of the numbers over here are greater than negative 1. They're all real numbers, they all have to be included, but not just the 0, 1, 2, 3 whole numbers. We have to include all the fractions and decimals in between those numbers. And the way we show this is we do shading in the positive direction, going on forever in the positive direction. P less than or equal to negative 3. Negative 3 is equal to negative 3, so it's in the answer. And then negative 4 and negative 5 are also less than negative 3, so they will be in the answer. And so will all the other negative numbers, including the decimals and fractions, so we have to use shading to show it. Going on forever in the negative direction. W greater than or equal to 2. 2 is equal to 2. All the numbers greater than 2 are that way, so we shade that way, including all of them, and go on forever in the positive direction. A less than or equal to 1. 1 is equal to 1, it is in the answer. All of these numbers are less than 1, so we shade to include all of them, and we go on forever in the negative direction. Let's do a few more examples of graphing and real numbers on the number line. These examples don't have the little or equal to line, and there is something new to do, something different. C greater than negative 3. Negative 3 is not part of the answer. Negative 2 is part of the answer, negative 1, and forever. We know we're going to be shading over here, but how do we show all those decimals and fractions between negative 3 and negative 2? Those are part of the answer. They are greater than negative 3. This number isn't. What we do is we put a circle on it, but we don't fill it in. That open circle means that negative 3 is not part of the answer. And then we shade from there to the right, going on forever. And this tells the person who reads the graph, negative 3 is not part of the answer, but all these numbers in between are part of the answer. Q less than negative 1. Negative 1 is not part of the answer, so we need an open circle. And then we shade to the left of it, going on forever in the negative direction. X greater than 2. 2 is not part of the answer, open circle. Shade everything to the right of it, going on forever in the positive direction. H less than 1. 1 is not part of the answer, open circle. We shade everything to the left of it, going on forever in the negative direction. So graphing in real numbers is very similar to graphing in integers, except that you have to do the shading, and if you don't have that extra little line, you need an open circle at the end, not a closed circle. Now you know how to graph on number lines. Use the exercise sheet to practice what you've learned, and then use the answer sheet to correct your own work.